morning, everyone. It's a pleasure to be part of this August gathering and this, on this stage with such eminent dignitaries. Uh, she articulated, I kind of wanted to bring forth the industry perspective. So while Ashok sir and Archana madam talked about the solution, what is required to make our water infrastructure more resilient. I wanted to touch base on how we can achieve that. So I represent Autodesk. I hope most of you, or some of you at least, would have heard of a software called AutoCAD, which is the original CAD, which helped the industry transition from paper-based drawings and drafting towards adopting a digital approach to the entire design and planning workflow. So our journey dates back 40 years. Okay, so yeah, our journey dates back 40 years, and in that 40-year period, we've grown far and further, integrating the newer inventions and newer innovations which happened within the industry. So today we develop solutions which span across different industries. Our core focus being around architecture, engineering, construction, while we cater to design and manufacturing or media and entertainment, so to speak. But the focus for us right now, as has been articulated by the speakers before me as well, is there is a huge upsurge or uptick that we are seeing in terms of metrics. So it's already envisioned that the global population is going to touch 10 billion, which will eventually lead up to a 55% increase in water demand. It's anticipated like 5 billion people living in cities might face some sort of water shortage. And then it also has a huge cost implication. So we see the impact of climate change, which is happening, and the events. I mean, very recently we've encountered floods, and they cause huge devastation to both property and life being more critical in that regard. So these are some metrics which articulate, the problem statement, almost $1 trillion worth of cost from an impact perspective. I don't want to, stress much on the recent events which happened, but the idea that probably I wanted to bring forth is how we can, if not prevent these kind of events, then what measures we can take from a technology landscape perspective to mitigate the impact, or how we can plan our infrastructure to be more resilient to withstand or to minimize the impact from such. So digital transformation is no longer optional. It's imminent, and I think a lot of agencies, water agencies, are already on the journey. So this whole digital transformation is also twofold. The first being the process of digitization, and the second being digitalization. Now, what I mean by that is digitization is moving away from the analog methods towards a more digital-first approach, where we are using, as Sir pointed out, and Archana Madam pointed out, as well as Prerna Ma'am pointed out, they're using IoT devices, sensors, in terms of getting real feedback from the ground in terms of how our infrastructure is operating. But then when we kind of define a process around it, is when the actual transformation happens. So that's where Autodesk comes into the picture, is in terms of connecting all stages of the water life cycle. And again, this is just to lay ground the emphasis that we've put forth on water infrastructure. And we have a huge footprint in terms of agencies and organizations, particularly in the public sector domain, who've already implemented our solutions. So coming back to the core point, so the idea is how we can integrate digital transformation, as we put it, from cloud to sea, how we span across the entire water life cycle, and provide you critical solutions which will help you plan, which will help you build, which will help you monitor all your infrastructure, water infrastructure assets in a more seamless way. Quickly going through the overall capabilities that we have to offer, while sir already mentioned in terms of the use cases. So from a planning perspective, how we are able to better leverage information coming in from different data sources. So whether it be data existing in GIS context, we have a lot of agencies already leveraging various GIS tools, which already publish a lot of information in terms of what exists on ground today. So being able to ingest that information and leverage that to calibrate our models better in terms of the changes that need to be reflected, in terms of the expansion that need to be planned, along with any sensor or SCADA or digital systems that are integrated on ground. Using that information to do water quality monitoring, using that information to being able to calibrate the model to analyze the impact of a particular event on the entire network per se. So that's what the role technology can play. That's what our solutions can do better. Sir also articulated the new buzzword which is spanning the industry, which is digital twins. Being able to create digital replicas of the actual physical infrastructure, and that's the whole process of digital transformation that we lay emphasis on. Being able to aggregate data from multiple sources into a common data environment, into a common repository which becomes the unified source of truth, and then being able to run predictive analytics in terms of analyzing or forecasting or doing what-if scenario kind of analysis to understand in case an incident occurs, then probably what will be the impact, and then planning any kind of mitigating measures that need to be incorporated. Developing early warning systems in terms of the system automatically flagging of any issue, obviously, any incident before the actual impact occurs. So those kind of things can directly be implementing, leveraging the technology. And similarly, on the downstream side, when we are talking about wastewater, how we can improve the reuse efficiency of our water system. So we have solutions which can actually do cityscape flood simulations by integrating data coming in, all different form, rainfall data, in case we have gauges installed within the city, we have that information. In case we have any other real-time telemetry data providing us the context. So we can simulate with better confidence in terms of the water infrastructure, water infrastructure that we are, or the system that we are trying to put, whether it will be able to withstand the impact of that particular incident. Just to give you a context, conventionally, this used to be a very manual process where, engineers had to do complex calculations, but their entire visualization always used to happen in the brain. So when we are trying to do that, there are always chances of oversight which used to happen. Now here is a system which gives me a visual feedback, and this, in this environment, we are not just considering the impact of the rain per se, but the interaction of the rain event or the flood event along with the existing, existing system, like the wastewater system that I might have, or the stormwater drainage network that I have. So how these two interactions will happen, and what part of the city or what part of the infrastructure will be inundated, so to speak, or there will be a overspill that we are going to see. So again, the idea remains similar. The intent is not just digitize the information for the sake of it, but to lead to a more predictable outcome, which is again, at the end of the day, being more customer-centric, ensuring that we have safer cities for our residents, we have better infrastructure for our residents, which is more resilient, so to speak. And then again, today we talk newer technologies. We're talking about AI being prevalent, but at the core of it, it is all about being able to leverage the same data that comes in from these sources. So being able to do real-time modeling using this stream of information which keeps flowing to me, and then forecasting, as Prerna ma'am pointed out, like they've already done that for the 2041 Drainage Master Plan that's coming up for Greater Noida. But then at the back end of it, there is a huge need of having these kind of technology solutions in place for being able to do that forecast modeling, or being able to do, because doing it conventionally, obviously, it's time consuming, it's tedious, and then probably there are always chances of manual oversights. And then, as I mentioned, using this information, we can learn from previous events. We can learn from the incidents that have occurred in the past and develop these EWS or early warning prediction systems, which will automatically, flag off any known pattern of activity, and then it will also share with me the impact of that particular event on particular nodes or particular zones or particular areas within the cityscape level. Next, I just wanted to quickly articulate. So I'm just going through the entire life cycle. Madam mentioned of developing these sewage treatment plants, developing water treatment plants, whether it be effluent treatment plants, whether it be, so any type of water treatment plant that we intend to design. So we have capabilities within the application to span the entire planning, design, and construction life cycle. Not just a digital twin of the linear infrastructure, but any vertical infrastructure that we are designing. And the aspect is, if a large part of this process could also be automated using artificial intelligence and generative principles, where the application kind of becomes my co-designer and gives me better design alternatives or better design predictions based on the constraints and the design rules that I specify. So that's the aspect of technology that we are trying to integrate within the core, design and planning workflows. Finally, coming to the operations and maintenance part of it, there are two critical aspects of this. One, being able to bring in real-time data in terms of monitoring the current health, current status of that particular asset. And when I talk in terms of an asset, we are going very granular. So I'm talking of a single pipe, a pump, a valve that's installed on site. So the idea is we start our process, and again, just taking a step back, because sir mentioned around it, today there are provisions or there are technologies which are available within Autodesk portfolio where you can automatically develop the entire network layout just by doing a survey scan on ground of the underground utilities that you might have. So you have GPR techniques, ground penetrating radar methodologies, through which you can survey the entire site. You bring that information within our tool, which can automatically develop a 3D digital twin model of the existing network as well. And then again, once we have that information, we can then connect it to a SCADA system or an IoT or a sensor, which will give me a real-time insight in terms of the current state. So sir mentioned of being able to detect leakages. So that's the technology behind how we can leverage those, or how we can kind of detect those leakages quickly and then take corrective action, so to speak. It's not working. Just move to the next slide. Right. So basically, the idea is to simplify for any operator to be able to understand the entire infrastructure that he needs to operate. A web-based platform, he just goes to any particular node, any particular equipment component that he needs to ensure is operating smoothly. He has the entire metadata, entire repository of that asset consolidated in that environment. And this is also, you're ingesting real-time operational data. It is not just static information which is created by the design or the engineering teams. This is all operational characteristics integrated in terms of the performance. So what's the flow of water in a particular pipe? What's the current quality level? So depending on what kind of outcome we want to achieve and what kind of systems we have incorporated, it kind of becomes unified in this environment. Move to the next slide, please. And just quickly, I know we were just running out of time, so I just wanted to cover two aspects. So the idea is today, I believe some of us would have already made use of some of the generative AI models that are gaining prominence in the industry, whether it be OpenAI or Gemini or any other cloud or any other tool. The idea is we are trying to also incorporate some of those techniques within the application, which will automatically detect scenarios. So let's say we are using some CCTVs or some cameras within our wastewater networks to be able to understand how the water is flowing. The application using image recognition techniques will automatically give you feedback in terms of what's currently wrong, or if you want to do a detailed root cause analysis in terms of how many pipes are operating smoothly, where there is some form of rusting happening, there is some form of corrective action required. So the entire root cause analysis could be done in a more predictive sense. Can you go to the next slide? So here you can look at how it's kind of detecting across those different images and identifying patterns, which obviously there is a machine learning model which based on which this application has been trained on. So it will give you not just recognition of that particular fault, but it will also give you a predictive mechanism in terms of what course of action needs to be taken so that we can mitigate the impact of that particular action. Can you go to the next slide? So here it's kind of automatically kind of identifying and distinguishing based on the entire network that it has scanned, how many components are functioning fine, where there are certain defects have been identifying, and then also doing a breakdown of the different types of defects. So you can take action more appropriately. Can you go to the next slide? And the essence of it is developing all of this in an integrated command center kind of environment where I can see the entire network for the entire city. And again, it could be all different types of networks, assets that we want to maintain in a unified repository and track different kinds of KPIs. So it could be in terms of operational KPIs, in terms of how much water got supplied to residential homes, how much water got supplied to institutions, how much water got supplied for irrigation, and then even from a maintenance perspective, like where the last mile connectivity, how much water from the systems that I've put, irrigation systems that I've put, was finally consumed by the from an agriculture perspective. So how much of it actually reached the farmer? So all of that could be integrated and unified. If you go to the next slide, and it all can be integrated in a single dashboard perspective, giving senior executives and senior management folks a complete visibility in terms of how water is being utilized, how and is there a mechanism to even optimize the systems. So with that, I just wanted to thank you for the opportunity, for giving us this time to share how Autodesk can become a partner to help connect the entire water life cycle right from planning through into operations. And thank you so much for giving us this stage. Okay, thank you.
Thanks a lot, sir. So thank you for telling us how Autodesk is addressing the technological gaps that are there in the water sector, water management and water resource management, and going the last mile to offer insights to the people who are involved in the water sector. So thank you for the presentation.